Logical operators. In this video, we will learn the three logical operators and how and why we use them. Suppose I write a program that asks the user to enter a number, and I want to determine if that number is between 1 and 5. If it is, it'll print so, and if not, it'll print that as well. One way to do that would be to use a multi-way statement. I would state if x is less than 1, then print not between 1 and 5. Else, if x is greater than 5, then print not between 1 and 5. And if both of those conditions are false, well then the only other possibility is that x is between 1 and 5. Hence, we'd print out between 1 and 5. Now, notice that the first two conditions both lead to the exact same output. Wouldn't it be nice if there was a way we could combine those two conditions into one so as to simply say, if either one of these two conditions are true, then print out not between 1 and 5? Fortunately, Python does provide a way, and it does so with the OR operator. We could state if x is less than 1 or x is greater than 5, then print out not between 1 and 5. Otherwise, print between 1 and 5. So what the OR operator is stating is that if either the left or the right condition is true, then execute the conditional statement. The OR operator doesn't need both of them to be true. It just needs at least one of them to be true. Now, suppose a student wants to determine his eligibility. So I ask that student to enter the number of absences that he or she has and the number of tardies. In this case, for the student to be eligible, I need not one, but two conditions to be true. The student needs to have 5 absences or less and 3 tardies or less, okay? Simply one of these conditions being true isn't enough. Both of them need to be true. Wouldn't it be nice if there was a way I could combine those two conditions so as to say if both of them are true, then let the student know that he or she is eligible. And if that is not the case, let the student know that he or she is ineligible. Fortunately, Python does provide a way through the AND operator. We could write if the absent variable is less than or equal to 5 and if the tardies variable is less than or equal to 3. If so, print eligible. Else, otherwise, print not eligible. The AND operator requires both conditions to be true for the entire expression to be true. If either one of them is false, then the entire full condition fails, and we move to the else condition. Now, suppose I ask the user to enter their age because I want to determine if the user is an adult or not. One way to do that would be to write if age is greater than 17, then print you are an adult. Otherwise, print you are not an adult. This program could also be written in a reverse manner. And here's what I mean by that. I could state if not age greater than 17, then print you are not an adult. Otherwise, print you are an adult. So for the original condition, rather than write if age is greater than 17, I'm essentially writing if the age is not greater than 17. Both of these approaches lead to the exact same behavior for your program. So in summary, in Python we have 3 logical operators. The AND operator, which evaluates the true if both the left and right conditions are true and false otherwise. Then there's the OR operator, which evaluates the true if one or both of the left and right conditions are true and false otherwise. And then lastly, there's the NOT operator, which simply flips the condition. If the condition is true, then the NOT operator will evaluate to false. And if the condition is false, then the NOT operator will evaluate to true. This behavior can also be represented using a truth table. For the AND operator, if both the left and right conditions are false, then the output is false. If the left condition is false, but the right condition is true, the output is still false. If the left condition is true and the right condition is false, output is still false. But if both left and right are true, then the output will be true. For the OR operator, if the left condition is false and the right condition is false, then the output is false. If the left condition is false, but the right condition is true, then the output is true. If the left condition is true, but the right condition is false, the output is still true. And if both conditions are true, then the output is true. Then for the NOT operator, which is a unary operator, it only receives one operand, if the one operand is false, then the output is true. And if the one operand is true, then the not operator will evaluate to false. We can also represent logical behavior using a dartboard analogy. Suppose I have a dartboard with two large circles, one labeled X and the other one labeled Y. And now let's say my goal is to shoot the dart and land it in the X circle. In that case, the dart would need to land somewhere in this region. Anywhere outside of that region would be considered the not of X. Now suppose I wanted to land the dart somewhere in the Y circle. Then in that case, I would need to land the dart somewhere in this region. Anywhere outside of that region would be considered the not of Y. Now, suppose I wanted to land the dart in both circles, in both X and Y. In that case, I would need to land the dart in this region. Anywhere outside of that region would be considered the not of X and Y. And now let's say I wanted to land my dart in either X or Y. It could be in one of the circles or both of them. In that case, the dart would need to land somewhere in this region. And anywhere outside of that region would be considered the not of X or Y.